Okay, so in the previous video, we said that we always need to regulate any step that's highly exergonic or has a very negative delta G. Typically in pathways, we're going to see that the first committed step and also the branch points are going to be highly exergonic, and those are steps that we need to regulate, and those are steps that are irreversible, so we must regulate them, because if they're irreversible and we go through that step, we're not going to be able to undo it if we make, let's say, if we, like, for example, make too much E or too much F, and this step is irreversible, we can't go backwards to C. So our body needs to have a way of regulating these steps, and I'm going to talk about that regulation now, okay? So to preface this, I want to say that you guys should always think of these things in terms of like what's logical or what makes sense. So I'm going to explain it in a second what I'm saying by this, but for example, if your body always wants to maintain constant concentrations of everything, and it wants to make sure like it's not wasting energy when it doesn't need to, it's not making this when it doesn't need to, it's not using up something if it doesn't need to do something. So this is the idea of biological efficiency, and also it wants to also be able to adapt to the needs of the body. So for example, if we get a decrease in the concentration of F, your body should be able to be flexible enough so that it can adapt and change the needs of the cells so that it can produce more F when it needs it, but also stop producing F when it doesn't need it. And this is the idea of homeostasis. We're trying to maintain relatively constant concentrations to meet the needs and the demands of the body. So that's what regulation helps us do. So there's two different types of regulation I'm going to be talking about. We're going to be talking about energy charge and feedback or feed forward. I don't know how you say it, but it'll make sense when I get to it. So we're going to first start off with energy charge, okay? So we're going to first talk about energy charge, and we're going to say that we can either have negative regulation by energy charge or positive regulation by energy charge. And there are two different conditions we have to consider, because depending on what condition we have, it's going to change how energy charge regulates that condition. So we're going to say that these are going to be like our conditions or like our pathways. So for example, let's just think about it like this, okay? We're going to go through this step by step. So if we had a biosynthetic, on this table I wrote biosynthetic, but on your study questions you could also see anabolic, or you could see degradative, or I don't know how to say that word, degradative, okay? Or and what degradative means is catabolic, okay? So I'm just going to use catabolic instead of saying that word so that I don't confuse myself. So I'm going to use catabolic and anabolic, okay? So in an anabolic pathway, right? So that's a biosynthetic pathway. What we're doing is we're taking two tiny things. So let's say it's like this big and then this big, and then we're using ATP energy, okay? And we're putting them together to make a bigger thing. And then we're taking another ATP, and we're putting something small again with it, and then it's making a bigger thing, and then a bigger thing, and then we're basically building something up, okay? So the idea here is anabolic pathways, they're building something up, they're making it larger, okay? And we know that in order to take two small things and build it up, we're going to require ATP. So let's think about this for a second. If it requires ATP in order for a biosynthetic pathway to operate, do you think ATP will positively regulate that pathway or negatively regulate that pathway? Well, if we had a surplus of ATP, right? If we had a lot of ATP, that means that we have a lot of energy. We can use the extra energy for whatever we desire. So what we could do is then the ATP could then come and activate these pathways so that we can build larger things up. And that's exactly what you see. For biosynthetic pathways, ATP is a positive regulator. But on the other hand, let's say that we don't have a lot of energy. So we only have AMP and /ADP. So we have a lower amount of energy equivalents. Okay? If we have lower energy, do you think you want to waste whatever energy you have left and build something larger up? So if let's say we don't have a lot of energy, do you think we're going to go through a pathway that requires a lot of extra energy? No. So the idea here is that if we had a lot of AMP and ADP, those are going to negatively regulate biosynthetic pathways, because we don't want to waste energy if we don't have a lot of it, okay? So all of these things, again, it follows a logical flow, okay? Now let's do it for catabolic pathways. Well, catabolic pathways, they're doing the opposite thing. They're going to be taking larger things and breaking them down to smaller things to get energy. So an example of this is, for example, like glycolysis. We're breaking down glucose, and as we break down glucose, we're forming energy equivalents in the form of ATP. So we go from the, so I'm just gonna this is like a very crude outline. We're gonna break it down into this thing, and we're gonna release an ATP. And then we're going to, again, break this one down into a smaller thing, and we're gonna release, again, ATP. So the idea here is as we're breaking this down, we're going to make more and more ATP. Well, let's think about it. Would we want to break stuff down if we already had a high amount of ATP? So for example, if let's say our body already had enough energy, do you think we're going to keep breaking down glucose to make more and more ATP? No, we don't want to make more ATP because we already have enough of it. So that means that ATP will negatively regulate these steps in the pathway so that we don't keep going to the pathway to make more ATP. And that's what it shows over here. So for degradative or catabolic pathways, ATP will negatively regulate those pathways because we already have enough energy. And now oppositely, let's go and let's just say we had a lot of ADP and AMP. Well, having a lot of ADP and AMP, what does that signify? Well, if we have a lot of ADP and AMP, this signifies that we have a lower amount of energy and our body is going to probably need more energy. So what ADP and AMP are going to do are they're going to go and positively regulate these irreversible steps, okay? And so that we can go through the pathway more quickly so that we can generate more ATP and make more energy for the needs of our body, okay? So the key idea here is that if you have enough energy, you're not going to want to go through a pathway that makes more energy, or if you are going to need or if a pathway requires energy to go through it, and we don't have enough energy, we're not going to want to go through that pathway so that we waste more energy, okay? So that's energy charge. Now we can also go to feedback or feed forward. I don't know how you want to say it, but the idea here is it's very straightforward. It's the same idea as ATP, okay? So let's say we had a lot of products in our pathway. So let's say in this one, we made a lot of F and G. So do you think that we're going to want to keep making, do you think our bodies are going to want to continue making F and G if we already have enough of it? No. So what F and G are going to do is they're going to feed back and inhibit this step. This is going to feed back and inhibit this step. And together, they're going to come back and inhibit that first step in the pathway, okay? So the idea here is that an increase in the products, they're going to be negative regulators in that pathway because you don't want to make more of the products. And then oppositely, if you had more reactants, well, if you had a buildup of A on the other hand, well, if we had a buildup of A, well, we're going to want to use up that A because we have too much of it, okay? So what's going to happen is A is going to come and positively regulate these steps so we can continue going through the pathway so that we can not have a buildup of A anymore. So again, the whole idea behind the regulation is so that we can maintain biological efficiency and flexibility, adapting to the needs of the body, but also not wasting energy when we don't need to.